right, today we're going to finish up on 6.7, which has to do with applications of rational expressions, and we're going to do a little bit about word problems. First of all, let me scoot this over a little bit so I can write a little bit here. It says a certain number is added to a numerator and subtracted from the denominator of 5/8. The new number equals the reciprocal of 5/8. Find the number. Well, first of all, a certain number is added to the numerator and subtracted from the denominator of 5/8. So we have 5/8. So I'm just going to go ahead and start and put 5/8. And we have a number that is added to the numerator and subtracted from the denominator, and it's equal to the reciprocal of 5/8. 5/8 is just 8/5. Now what I need to do is I need to solve for x. Now you guys, because you have a ratio, so sorry, my clock is going. If I have a ratio equal to a ratio, all you have to do is cross multiply. That's what I would do. Or you can multiply the whole thing by a common denominator. I personally would just cross multiply. So I'm going to take this here and I'm going to multiply it by 8. I'm going to just talk louder. So I have 8 times 8 minus x equals, I'm going to take this 5 and I'm going to multiply it by 5 plus x. So this is going to be 5 plus x. Now, because I'm running out of room, I'm going to go ahead and I'm going to have to distribute this. 8 times 8 is 64. 8 times negative x is a negative 8x equals 5 times 5 is 25. 5 times x is 5x. Now my goal is to get x's on one side, numbers on the other. So I'm going to minus 25 from both sides, and I'm going to add 8x to both sides. Because I'm just trying to solve what that number is. So 64, let me do some borrowing because I don't have a calculator on me at the moment. So that's going to be 9, that's going to be 39 equals 8, 9, 10, 11, 12, 13, x. I'm going to then divide both sides by 13, and x equals 3. So if x equals 3, that is the number that we're talking about. So like I said, there were so many different ways you guys could have solved that equation. I just used cross multiplication because I had a ratio equal to a ratio. No big deal there. All right, let's go to the next problem. The next problem is using the distance formula. D equals RT. Once again, you can rearrange that equation depending on what you're looking for. And here is my first problem. So my first problem, you could go ahead and draw a picture. It would make life a little bit easier. A boat can travel 16 miles against a current in the same time it can travel 40 miles with the current. The current flows at 3 miles per hour. What is the rate of the boat in still water? Let x be the rate of the boat in still water. So next slide just means that I have extra room, but I'm going to just try to write everything else up in here. All right. So first of all, let's start with the boat can travel 16 miles against the current in the same time that it can travel 40 miles with the current. So I'm just going to draw a little picture, and I'm going to draw a little picture. Okay, the first one is going to be 16 miles, and this one here is going to be 40 miles. Okay. Now, a boat can travel 16 miles against the current. So we're assuming, let's say the boats are going in this direction. So this one here, it would be the current flow is at 3 miles per hour. So if it's against the current, it's going to be x minus 3. For with the current, it would be x plus 3. Because the rate is 3 miles per hour. So the current would be, we don't know what that, we're going to let x be the rate of the boat. So if the boat is going against the current, it would be, of course, minusing the 3. If it's with the current, it would be plus 3. All right. So now what we're going to do is we're going to find the time it takes for it to travel with the current and then without the current. So let's go ahead and work that out. So I have, I'll just do it over here. T equals distance over rate. So that would be distance over rate. So it'd be 40 miles over x plus 3. And that would be with the current. Okay. And then we'd have t equals, what is it again? 16 miles over x minus 3. And this is against the current. And I'll tell you guys a secret. I don't like these either. Sorry. It's my phone. And so then what I end up with is t equals t, and we all know that's true. So I can set both of these ratios equal to each other. So I'm going to go 40 x plus 3 equals 16 x minus 3. Again, just like the problem we did earlier, I'm going to just cross multiply. No stress whatsoever. I'm going to take x plus 3 and I'm going to multiply it by 16. So 16 times x plus 3 equals, I'm going to take this and I'm going to multiply it by 40. That's going to give me 40 times x minus 3. Now I'm going to have to do a little bit of math. So I'm going to get 16x plus 16 times 3 is 48, I believe. I don't have a calculator with me today, so hopefully the numbers are right. Equals 40 times x is 40x. 40 times a negative 3 is a negative 120. And again, now I'm just trying to get x's on one side, numbers on the other, no stress whatsoever. So let's move the 16 over. I like to move the smaller of the x's. It just, I don't know why, but I've always done that. And then I'm going to add the 120 to both sides. So then I'm left with 168 on one side. And again, that's 3. So here's 4, 24x. Now I want to get x by itself. Once again, I don't have a calculator. So I left it in the other room. So I have this here. So I end up with x equals, actually, I have my phone. Hello. Let me divide it. 168 divided by, sometimes I forget, 7. So it's going to be, if the boat were just to be in what do you call it, still water, it would just be, the rate would be 7. So just plain old 7. That's it. Plain old 7 miles per hour. I'm trying to multitask right now. I'm so sorry. So if the boat is in still water, it would be 7 miles per hour. If it was in, if it was going against the current, I would take 3 from that, and it would be 4 miles per hour. If it was with the current, it would be 7 plus 3, which would be 10 miles per hour. They just want to know what it would be in still water, and it would be 7 miles per hour. All right. Sorry about that. So let's do the next one. The next one, I'm going to do this problem just a little bit different, just to kind of make it a little bit easier for you. So what I'm going to have you guys do is this. I know that there's some notes in here that, especially like this one here, it's still the same. This is my formula. It's the time over how much time it took the individual to do the work. So here's my problem. Al and Mario operate a small roofing company. Mario can roof an average house alone in 9 hours. So we don't know how, I just know that his job is Mario can work 9 hours, okay? And then he can finish the job. We want to know how much it is that they work together. So then if I talk about the other guy is Al. He can roof a house alone in 8 hours. But we want to know how long it will take them to work on this job if they work together. Well, the job is just one job. We want to know how long it's going to take them to work together in one job. So here's my little equation. Just like what we've done in the past, we don't like fractions. So we're going to get rid of the fraction. I'm going to multiply this whole thing by 72. You might want to know where I got 72 from. You guys, I just multiplied 9 times 8 together. I got 72, and I'm going to stick with 72. There might be another number that they both can go into. I don't know what it is. I just multiplied them together. I figured, let's just do that. So 72 times this. First of all, 72 divided by 9 is 8. 8 times x is 8x. 72 times x over 8 gives you 72 divided by 8 is 9. 9 times x is 9x. Then 72 times 1 is 72. So now you just clean this up a little. 8x plus 9x is 17x equals 72. Now I want to go ahead and get x by itself. So I'm going to divide by 17. I don't think this goes in evenly, so I bet you it's going to give me a fraction. I'm going to go ahead and let me go back through here and let's check it out. I'm answering the email. I'm so sorry. Here we go. So they want to know how long will it take them to do the job if they work together. 72 divided by 17, I get 4 hours. Let's just do the hundreds place. 24. So 4.24 hours to complete together. Okay? Together. Now you could be technical. You could figure out the exact amount of minutes if you wanted to. But we're good. All right. So I believe this is, do we have more of these? How long will it take the job? Let's do this one. This is our last one. So we have 2 people again. OC can mow an average along, so it's going to be x over 4. And Candence can mow alone for 6 hours. How long will it take them to do the job if they work together? Same idea. This is OCI, this is Candence, and together that's just one job. So we're going to multiply this whole thing. Now, instead of multiplying these 2 numbers together, I know that they both can go into 12. So I'm going to use 12 this time. This here gives me 3x. This here gives me 2x. 12 divided by 4 is 3. 3 times x is 3x. 12 divided by 6 is 2. 2 times x is 2x. And then 12 times 1 is 12. So I get 5x equals 12. Again, I'm going to divide by 5. And I'm going to get x equals, I'm assuming it goes in there twice, 2.4 hours. So together it'll take them 2.4 hours. Again, we can break it down to be a little bit more specific if we want to know how many minutes actually, but 2.4 is totally fine with me. All right, you guys, I hope you have a great day. Enjoy your afternoon. And in this case, when I'm filming this is actually Thanksgiving weekend. Enjoy your weekend. All right, good night, you guys.